All right, let's see. Let me get the link to my stream. That's the one thing I can't quite figure out with Twitter. I'm not Twitter, YouTube. Is once I start streaming, where, oh, there it is. I see it now. Advent of code, day 4 and maybe 5. Okay. Let's see. That over here. Make that full screen. Okay. Trying to see if this is readable on stream. A little small. All right, we'll do that. Okay, well, good morning. This coffee is delicious. I'm ready to work on day 4. I worked a little bit on it last night. And it took kind of a long time because I was also learning Nom. So I'm going to start by sort of explaining what I have with Nom, the parsing library. And I do like it a lot, but I'm sure that my usage of it is not ideal and could probably improve. So Nom has a whole bunch of different modules that you can pull in for different things. So that's what all these use statements are. We're going to call parse cards in the input, and this is going to return to us an iResult. An iResult is a type alias, which takes an input type, which is our string slice, an output type, which is our vec of cards, and then an optional error type. So the error type defaults to some built-in error. So when we parse cards, let's do this. Parse cards takes the input as a string slice. So one of the things to point out here is that I took the string from, in this case, the input.txt, and we're literally looking at the same string. We're just looking at the shared reference to that string, and sometimes a string slice is just like a portion of that string, but it's still one string in memory. So this returns an iResult, passing along the input type, and what ends up getting returned is the input that is not yet parsed, and then the result that we just picked up. So in this case, a vec of cards. So this is kind of like our final state. And if we take a look at our test here, this is what these look like. We end up parsing these out. This is a single line to parse a card. We'll ignore that for a second. So I'm using Nom's separated list parser. Hey Samuel, how are you? How was your trip? So we're using separated list, and separated list. I don't really know how to read these method signatures when they look like this because the generics don't really help that much. But if you take a look just at the part that says sep and f. Sep is the separator, so it's a parser that is going to eat the separator and discard it. And then the f is a parser that's going to parse the rest of it and give it to you. So in this case, ignoring cut for a second, in this case we're saying our separator's a line ending, throw that away, and for everything else, continue to give me the result of parsing the card. The cut parser is an interesting one. I'm not quite sure how to read this, but I came across it in the docs and it was actually really helpful. So I think that separated list, if something fails in this parser on one of the rows, it will by default just skip over and keep parsing the rest of the input. So what that would end up is you would it'll just stop the parser and return. So in this case, let's say I had like an error on card 3 that wasn't an integer. Then what would happen is I would get card 1, get card 2, and then that would be the end of it. If you wanted to stop and give you the error, then you can use cut, which will do exactly that. It'll stop at the error and print it out for you. I'm okay. Trip was good. How are you doing? I'm doing pretty well. I'm starting to realize that admin of code is a huge time sink, just like last year. And I don't know how many days I'll be able to do this. I feel super behind. But I am having fun. Okay, so this is how we parse all the cards. How do we parse a single card? And this is where the code gets a little bit, like, I'm sure that this could all be improved a lot. So we'll start with this one. This is a single line of code. So we start with the So we're saying that we're going to precede something and then a number. So that's what our cards looks like. So it's preceding something and then a number. And the reason why the something isn't just card space is because as you get farther and farther along in your input, these are aligned. All these numbers are aligned in like a grid. So because the last ones are 3 digits, these have 3 spaces. And so what I'm trying to do here is parse where is it? Parse card here. We're saying that I'm using a terminated sequence, or it's a parser, that takes this literal card followed by 1 or more spaces. So the terminated parser will return to you this thing and discard that thing. The preceded parser will throw away this part of it and return to you this thing. So that's how I get just the ID of this card. And then that returns to you a parser that you then call with your input. So the return value of that is a result. And Rust has this question mark syntax. So if your method also returns that same result, then you can put a question mark here and it will just sort of halt here and throw the error at that point. There's no throws in Rust, but that's basically the way that you sort of bail out early and return a result with an error if an error occurred on that line. So what that returns to you is the remaining input that we have yet to parse, and then the thing that we just plucked out, which in this case is a use32 because we used this parser. So then I'm doing this thing to grab any number of white space before this literal colon followed by 1 or more white space, call that on the input. I don't care about the result here. So in this case, I think all 3 of these could be combined. The whole thing can be combined. Like the idea of nom is it's a composable, what they call a parser combinator. So all these things get combined together to create one big parser. But the cool thing is you're still only operating on the string slice. So it's like plucking out the data and shifting the position that you're at. And at the very end, I get the numbers that are on the left side of the pipe and then the winning numbers, which are on the right side of the pipe. And so then I debug that. So if I do cargo test part 1, unresolved input part 2. I think that this one, save it, lib. Oh yeah, I need pub mod part 2 because I started on part 2 just by copying the result of part 1. Could not compile. format total not found in the scope, and that's again in part 2, which we're not actually caring about right now. So let's go to here. Let's just do this. Oh wait, that was part 1. Goodness. I was reading this little 2. I'm not quite sure what that 2 is for. And so that's why that was confusing. All right, part 2.rs, and yeah, there's no total. Unused import self. Sure. Remove unused imports. Okay, and then our test passes, and if we want to see that debug output, we can do dash dash no capture, I think. Separated by dash dash. Yeah. Okay, so then this is the cards that get parsed out. So those are our cards, and each one is a hash set. And what we're doing is we are getting the values by intersecting the two. I thought about this later that really I just need to intersect my numbers with the winners to get the winning numbers that I have. But I just called this by iterating and then doing contains, which is fine because part 1 is done. But now that we're on part 2, let's do we're going to do cargo watch dash clean, quiet, and execute. We're going to do test part 2 dash 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 no capture. Okay. So at this point now, winning numbers, I just want to change this to do the intersection. So nums is a hash set. And we can do intersection with self.winners. And then collect that into a vec and see if that does what we want. I need to borrow this one. Okay, so that was easier. There's one other thing I want to look up. I saw this on a previous Advent of Code stream, and it is RS test, and I don't know if that's a separate crate or if this is something built in. And what this does is create RS test. So I'm pretty sure that I need to pull this in. But what you can do with this is, if we make use of RS tests, we can isolate dependencies, pass them as fixtures, and there's cases. Yeah, this is what I wanted to use it for. So let's try this out. I'm going to cargo add RS test. Okay, so this one should still work if I just do RS test. Okay, so I need to import RS test. Okay, so that still works, which is great. What did I just do? Undo, redo, redo, redo. I'm not sure what I did there. Okay, so we're in part 2. So what I want to do is I want to test the individual inputs. And here I want to do RS test and then we have cases, and then the test takes that input, each one marked with the case. So I'm going to say that, let's do this, copy this, copy this. I'm going to line everything up so it looks like this. All right, so at this point now, where I'm going to do case with a string like that, but I want to do it for every line, so let's do some multi-cursor wizardry. That's going to be case, no, case, quote, end line, close, close. And then indent everything. Okay, so now our input needs to take each one of those. Oh, and we need the expected output as well. So I don't know what the expected output is supposed to be. So I'm going to do more multi-cursors. The keyboard command that's by default for VS Code, it conflicts with something I have on my system, and I need to fix it because I will do this a lot. I do it a lot in Xcode too. Okay, let's give this a result of 0 to make sure that they all pass. And so then this is going to take a case of line, which will be a string slice, and then case of answer, which will be an integer, 32. Okay, so this one failed, but did the others run? 6 passed. That can't be right. Oh, I'm not doing any assertions. Well, that would be why. Okay, so I can do let card equals parse card. I'm going to take the line as the input. When I'm going to expect that is expect parse line or parse card. And then that gives me a tuple, so I'm going to pull out the first element. And what I need to know, let's look at the input from Advent of Code. Not the input, the prompt. All right, so what I'm supposed to be doing here, each one, card 1 has 4 matching numbers. So we figure out how many matching numbers each one has. Then you win a copy of each of the next 4 cards, 2, 3, 4, and 5. Your original card 2 has 2 matching numbers, so you win 1 copy of cards 3 and 4. Okay. I'm not sure if the line test actually helps me here because I can't really run this in isolation. I already know that I get the count. So let me just put those in. Card 1 has 4 matching numbers. Once all of the originals and copies have been processed, you end up with 1 instance of, oh, okay. So I do want to do this. So I want to do 1 instance of card 1, 2 instances of card 2, but I actually can't run the test like this because I need the whole input to run it. So let me just do the matches just so we have an example of RS test cases working. Your original card 2 has 2 matching numbers. Card 4 and then 8. 4 and then 8. And then Wait, no, that's not gonna work. Okay, I'm just going to run it so we see what how many matches we have. Assert equal card dot winning numbers dot len is equal to the answer, and then we'll see what the result is, because I'm pretty confident that these work. Answer try into dot unwrap use 32 dot use size. Okay, well that could be a use size. Okay. Probably want to get rid of our debug output because we know we're parsing the cards correctly. So let's get rid of that. Okay, so it gives you these cases, and then we're missing case 3 was supposed to be 2 here. Then this one was supposed to be 1. And 0, 0 for the rest. Okay. Okay, so when we are processing the whole input, we're going to, let's see, I have the struct for inventory, so I'm thinking we'll take, I don't even know if I need this actually, because what I want to do is in the process function, we have all of our cards. So if I take those cards and I reduce, I just found a bug in my I just found a bug in my side mirror app. Every time the dock moves to a new display, it stopped. Oh man, okay. That's amazing. I've been trying to find that bug for a long time. Okay. So what I want to do is reduce the cards. It's not reduce, it's fold, and that's on itters. Fold. So the initial value is going to be like an empty hash map. Let's call this inventory. And that's going to be a hash map of the card ID to the count. Hash map dot new, and I need to give it the key and the value. And that goes here. Key is going to be the card ID, which is U32, and the count will be a U32. Okay, does that work? So fold is going to take inventory as the initial value, and then it's going to take a function that takes our accumulated value and then this card. And so we start off at card 1. I wonder if there's a way for me to set the default value for all items in here. I could insert them because we have one of each card. So we're going to have to get in the, I'm going to call this INV so that we can see what it is. This is going to be inventory dot, I know there's get. No. What's happening with INV? That one should be, oh, it's a empty type. Oh, this isn't working. That hash map. Oh, the colons go here. Okay. Okay, now I can turn those off. Okay, inventory dot get. It's still complaining. That. Oh, I also need a new, or I need a dot new. No, I need this new. Is that right? Okay, now I have a hash map of, okay, perfect. So inventory.get should get the inventory for this card ID. And that returns an optional. Okay, that could work. We'll do card.id to get the inventory. We're going to unwrap or return 1. Count of card. Let's just do count. Now we can do for I in because what I want to do is figure out what this card's score is. That's the card's winning numbers dot length. And so it's going to be 0 dot dot score. And that means we're going to take card card.id plus I as the new key. And we're going to update the inventory and get mutable. I'm not quite sure. Let's find out. Rust hash map. Okay, so here we have a new hash map. We insert a value. We can change the value with get mute. Okay, what about entry? Entry. Gets the given key's corresponding entry in the map for in-place manipulation. Not quite sure what the difference. Entry and modify. Okay, maybe that's what we want. Okay, so if we did inv.entry, that gives me an entry of this card and modify. And that gives me a new value. And I think I do star to modify it, or do I return a new value? So we get the counter and we dereference it. Or insert 1, which is interesting. That could be another way that we get it. But this is kind of how it works. Oh, we definitely need it to be +1, because if there is no entry, then we need to insert an additional 1. Yeah, I think I'm just going to do this real quick. For card in cards, inventory dot set. Can I just do card.id? How do we just plain set? Insert. Yeah. We're going to insert card.id and the value as 1. So all the cards should have a value, which means that now we can just unwrap it inside of here. Okay, so we get the score for this card. Then in the entry, we call modify. Now we have a V. I don't think I really need a multi-line closure here. I'm going to do, the value is going to now plus equals 1 because I just got one more copy of that card. Okay, so I kind of want to say card card.id has score oh wait, not his card, that's going to be this and this, that's going to be card.id and score. And then after print line, we'll just debug inventory after each line, and hopefully that should be fine. And then at the very end, I need to return our new inventory. What is it complaining about here? U32, this is a U32, I is a U size. Can I do U32 here? And try into.unwrap to convert it. Okay. Cards.iter.value borrowed here after move. Okay. Let's go up to the top and clean up some of this stuff. I result multi-separated list self. Is that in part 1? Yeah, it is. Let's go to part 1 and clean that up. Okay. Then in part 2, count is not used. It needs to be used because for that card that I'm on, I need to run it that many times. And maybe I could just do plus equals count here rather than looping again. Okay. Cannot borrow this as mutable. Well, we should be able to. It is also borrowed as immutable. Count, inventory, get, okay, let me go up to the top. Okay, that's the top of the error. Cannot borrow inventory as mutable. Immutable borrow occurs here. Immutable borrow later captured here by the closure. Move occurs because inventory is type hash map, which does not implement the copy trait. Okay. And then we use this after the move. I'm not sure if we just need to do something like that. And now we have a count here. I don't know if that actually helped us at all. right, let's do a quick search. Rust hash map fold. Let's see if we can get an example of that. I don't really want that. This is what I think I need. So this is creating a scope to make sure that counter doesn't. Let's see, a new scope to constrain the mutable borrow. Okay, so you have a mutable borrow that still exists because we're borrowing. Yeah, okay. So we're reaching into the accumulator. We're getting the entry in order to mutate it. So that borrows this as immutable. So do we have the same problem in our code? We have entry and modify. I don't know if that matters. If I did this, I don't think that will do anything. No. Unless count is the reason for that. No. Okay, hang on. Let me double check that post again. All right, let's go. All right, let's simplify this by not doing that. Just start looking at the issues here. Warn unused variables. Unused variable does not need to be mutable. Use of moved value INV. Let me get rid of the debug and make sure that that's not the problem. Trying to clean up this output so I can focus on the actual problem. Cannot borrow inventory as mutable. It is not declared as mutable. Well, that would help. Borrow of move value cards. We can do that. Okay, so we are now compiling. Okay, so now let's try this. Cannot borrow INV as mutable because also borrowed as immutable. Immutable borrow occurs here. because I need to know the count. I don't know if maybe like cloning helps. It does. So it copies the count into this variable here. And that leaves it free for us to then mutate it here. Okay. And if I call this, now it can work. Okay. Getting closer. So now we can see what's happening when we call process on the sample input. We need to sum them at the very end, so let's just see what we get here in the process function. So at the very end of it all, we have our inventory, and now we need to do let sum or total equals inventory. That actually returns here, so we can just do iter.sum. Let's do let total equal dot values dot sum. And then here we will format the total and return it as a string. This needs to be, say, a U32, so it knows what to sum inside of. Okay, and we got 28. I think the answer said it should have been 30, so we have a problem there. Our test should say 30. And since we printed it out each step of the way, hopefully we can see what's going on here. Let's get rid of you. All right, so what I want to do is compare each step of the way. Let me get rid of that warning real quick. Allow dead code. Okay, card 1 has score 4. Card 1 has 4 matching numbers, so you win a copy of each of the following 4 cards: 2, 3, 4, and 5. So if I look at card 2, it should have 2, 3 should have 2, 4 should have 2, and 5. That's wrong. I think that my for loop needs to, where is it? Here. 0 up to score. I think I want 1 up to an equal score, because that ended up adding 1 to card 1, which is not what we wanted. So I'm going to save that, and now our test passes. Okay, let's run this on the actual input. So let's go to parse part 2 in the bin folder. Yeah, we are running that. So let's do cargo run bin part 2. That is a nice round number. Okay, that's it. Good timing. Definitely don't have enough time to get into day 5, but maybe I could just get the project set up and read it. So let's look here. We're only in day 4, so let's close that. My term. Commit-m day 4. Okay, what was cool about that one is I learned nom and rs test, which I think if I sort of have a goal of learning something new every day, that's a good goal, because I'm not going to get through all of Advent of Code. I already know, but my goal is not to finish it. My goal is to learn stuff about Rust. Okay, day 5. Actually want to try one different thing. I want to do --lib and see if that, oops, that's not what I wanted. Oh, you can't see my terminal. There we go. I want to do cargo new --lib and then open that up here. Yeah, and then can I do a new file? No, new directory, bin, part1.rs, lib. Don't need any of that. This is going to be pubmod part1. New file here, part1.rs. Pub function process, input string slice. And then that will be format part1. Okay, cargo run. Let's go into day 5. Cargo run. And there's no main function because we need to put it in here. So function main. And then this one needs to use create day. Is it day 5? Part1 process. Let input equals empty string slice for now. Then print line part1 process input. Okay, let's take a look at the actual puzzle. Let's share that on Mastodon real quick. Oh, looks like my Mastodon server is just totally down. Yep. All right. So I won't share that right now. All right. Let's take a look at day 5 and just read the puzzle. Okay. If you give a seed of fertilizer, you take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. A water source, Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more, and soon. We only turned off the water for a few days, weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than the boat. Can you please go check it out? You barely have time to agree when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest island almanac arrived, and we're having trouble making sense of it. The almanac, your puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every seed, soil, fertilizer, and so on is identified with a number, but the numbers aren't reused by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. For example, so we have these seeds, seed to soil map, soil to fertilizer map, fertilizer to water map. Okay. The almanac starts by listing which seeds to be planted, seeds 79, 14, 15. The rest of the almanac has a list of maps which describe how to convert numbers from a source category into number into destination category. Okay. Consider again the seed to soil map, 50, 98, 2, 52, 50, 48. The first line is a destination range start of 50, a source range start of 98, and a range length of 2. This line means that the source range starts at 98, contains two values, 98 and 99. The destination range is the same length, but it starts at 50, so its two values are 50 and 51. With this information, you know that the seed number 98 corresponds to soil number 50. Seed number 99 corresponds to soil number 51. Okay. So the entire list of seed numbers and their corresponding soil numbers looks like this. With this map, you can look up the soil number required for each initial seed number. Okay, let's take a look at just getting some quick parsing done. I've got about 10 minutes left. I definitely want to add nom here, and I also want to add rs test, and I want to try something called indoc. Cargo add nom rs test and indoc. And the reason for those, so in part 1, let's do CFG test, mod test. Inside of here, say I have a test sample input, and lately I've been doing let input equals and just pasting that, but the problem is that these end up with leading white space in the string, so I've been having to outdent them and it looks kind of terrible. But indoc has a macro. I may probably need to go look at what this looks like. Indoc. Okay, so what happens here is it trims all the leading white space. Yeah. So I do indoc quote and then end quote here, and then let's just get rid of all of this and then paste that again. All right, so it's just a little easier to read. All right, so what I think we're going to end up needing here is seeds are just numbers, but then we have a bunch of maps. And the maps take a source index, let's call this a source map. it'll have a name, which will be a string. And the string will have the same lifetime as this, I think. I think that's how you do that. Let's do cargo watch dash CQX test part 1. I can never remember this. Tick A and string. Maybe that's it. Okay. So what I was thinking here is the source map would have the source range, which would be a range inclusive of U32. No, use size maybe? Trying to think of what, there's probably U32 that we want. And then we have a destination range. So this is going to be, yeah, also a range inclusive U32, I think. So soil to fertilizer is going to be, yeah, is going to be the name. So we're going to have, let's add our comma here. So parsing seeds, let's say we're going to parse input is going to return to us an I result from nom of our source string. Then our input is going to be two things. It's going to be it's going to be a list of seeds, so vec of U32. I could do type seed equals U32 so that we can give this a better name, vec of seed. Then I want all the maps, but those could be hash maps. So I wonder if source map is just source and destination ranges. So if I do hash map here and import that, this is going to be a hash map of a string key followed by a source map structure. I think that's what I want. Okay, then this needs that. Okay, parse input needs to take the string slice. Input string slice. And then this is going to end up being some nom stuff to say parse seeds, which will take input string, return an I results of a string and a vec of seed. And the thing that I'm going to end up doing is saying like, okay, I'll eat this line, split this, and then the rest of them are just going to be maps that are named that I can then iterate over and look up. I think that's what I want here. And I'm basically out of time, so maybe I could just do the seeds one. So this one is going to take the input, eat seeds, and then get the list of numbers. So this one is going to be preceded. The first one is going to be a tag of seeds : space. And we might want to just double check our input that we allow any number of white space. We probably need to. So that is going to be terminated tag seeds. And this is going to be multi-space. But we don't want new lines here. I think I just want space. Space 1. And then this one is our list of numbers. Let's do this. Import nom sequence terminated. Yes. Import tag. And that's going to be nom complete tag. And then here, import space 1, nom character complete space 1. All right. Now we have a separated list with at least one element. The separator is white space, so we'll do space 1. And then this one is a complete U32. We want to do this one, import complete, which is nom character complete, because we're parsing the U32 as from characters. Okay, and so I think that this is enough to give us the, sorry, this is for seeds. This needs to go here. This one can be a to-do, so we can satisfy the compiler. We don't need the lifetime anymore on the source map here. This one, preceded term. Okay, so hang on. So terminated takes the first item and then the second item. So in this case, we have terminated to ABC and EFG. So when we parse that, we should get back just the ABC. Yep, and it eats the rest of the input. So that's how that works. So terminated seeds colon with a space. And this one is preceded, which takes the preceded key. Let me make sure that that is the same. Preceded ABC, tag EFG, so we should be getting EFG here, and we do. Still don't quite understand what's happening here. The trait from U8 is not implemented for string, so I think maybe I'm using the wrong tag. I think I want character tag. Let's see. Import. No, I want nom complete tag. That's right. Okay. Looks like I'm just going to leave it on this error, and I'll figure this out next time. But basically, we'll parse the seeds. We'll get back that. Then we'll write a function that will parse a source map. And that's going to take the input of the string, and it's going to return an I result of the string followed by the name of the source map and then the source map itself. And then that one will then be collected into a big hash table or hash map so that we can process the input. So I think that's where I'm going. I'll figure this part out next time, and thanks for watching.